Hi, it's Zoe with Hoffman Tutoring Group, and today I'm going to show you how to divide a whole number by a unit fraction. So stay tuned if that's something that you want to find out about. I'm going to give us our first problem here. So we're going to start by dividing 4 divided by 1/2. And this may seem a little strange to you if you've never seen fractions in a division problem before. And before we start this problem, we're going to think about what it means to divide. So let's think about an easier number set here. So let's think about 6 divided by 2. We've all done 6 divided by 2 before, and we already probably know that the answer is 3. But there's 2 different ways to think about division. So first we could think about, okay, how many groups of 2 are in 6? So how many times could I scoop out 2 if I have 6 objects? So we might look at it and make a model. So we might say 1, 2, 3, 4, 5, 6. That's what I have here. And then how many groups of 2? I would circle 1 group of 2, 2 groups of 2, and 3 groups of 2. So that's one way we think about division. And then the other way is having 6 objects here. So 1, 2, 3, 4, 5, 6. And if I'm dividing it by 2, I want to have 2 equal groups is another way to think about it. So if I split this into 2 equal groups, there would be 3 objects in each group. And the way that we're going to think about this problem right here, the 4 divided by 1/2, is to think about how many 1/2s are in 4. So we're going to be thinking about that first situation where we have 4 and we want to see how many groups of 1/2 are there. So what I'm going to do is I'm going to model this, and I would encourage you to model this on your paper as well. I'm going to get 4 holes. So I'm going to draw 4 rectangles, 1, 2, 3, 4, and they don't have to be perfect, but we want them to represent holes, so they need to be roughly the same size. And then I want to see how many 1/2s are in 4. So I'm going to split each of these holes in half. So splitting them into 2 equal parts. All right, now we have our model split into halves. And so now I want to count how many 1/2s are in 4. So I'm going to count here. So I'm going to count, getting my marker up here, 1, 2, 3, 4, 5, 6, 7, 8 halves. Can you see? 1, 2, 3, 4, 5, 6, 7, 8 1/2 groups. And so here we would say 4 divided by 1/2 is 8. And we can get into later why we're getting a number that is bigger than both of these numbers that are in my problem. Usually I'm used to something that's smaller when I'm using whole numbers. But another way we can think about this 4 divided by 2 is to look at what we did here. We have 2 halves in each hole, and we have 4 holes. So something that we also did is we did the problem 4 times 2. And you can see that's also 8 because I have 4 holes, and then there are 2 halves in each of those holes. So I could also count these by 2, 2, 4, 6, 8. All right, let's look at another problem to help you grasp this a little bit better. So the next problem we're going to look at is 3 divided by 1/5. So again, what we're looking at is how many 1/5 groups are in 3. So how many 1/5 groups are in 3? So first, again, we're going to do our model. So I'm going to draw 3 holes this time. And this time I'm going to make them just a little bit bigger since we're splitting them into fifths. And since there's only 3 of them, I have a little bit more room. So here are my holes. I have 3 holes, but I need to figure out how many 1/5 units are in 3. So I'm going to split each unit into 5 equal pieces to see how many 1/5s are in there. So I'm going to split, and I'm going to try to do it as accurately as possible. So 1, 2, 3, 4. You can see I'm not totally accurate, but I'm trying my best. 2, 3, 4, and that's all that matters. 1, 2, 3, 4. You can see here I drew 4 lines on each one, but I'm splitting them into 5 equal pieces. So now I want to know how many 1/5 units are there. So we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 3 divided by 1/5, there are 15 1/5 units in 3. 15 1/5 units. And so we can also see here there's a multiplication problem that we did is there are 5 1/5 units in a whole, and we have 3 wholes. So we could also skip count 5, 10, 15, or we could say 3 times 5 equals 15. And I want you to see if you are seeing a pattern with what our multiplication is related to our division. Can you see something that's going on there? We're going to talk about it in the next one. So in the next one, I'm going to write out the problem, but I'm going to try to give us a little context. So the next one is 5 divided by 1/3. So maybe I'm at a pizza party and there are 5 pizzas, and each person, so a serving of pizza is going to be 1/3 of a pizza. So if I have 5 pizzas and I want to know how many servings I have, I'm going to need to figure out how many 1/3 are in 5, or how many 1/3 pizzas we have to figure out what our serving is. So again, we can draw a model to figure this out. I love drawing models to figure these fraction problems out. So I'm going to draw 5 squares. I know it would probably be more realistic to draw circles since we're talking about pizzas, but I like the square model because it's easier to partition into those thirds, and thirds on a circle is pretty hard. Okay, so we have our 5 holes, or our 5 pizzas. Maybe they're square pizzas. I've seen those before. And we're going to partition them into thirds because each serving, remember, is a third of a pizza. So we want to know how many thirds we have. So I'm going to partition these into thirds. Again, just trying my best to be accurate, but it's not going to be perfect, and that's okay. So splitting into thirds, splitting into thirds. All right. So now I have my model split into thirds, or my pizza split into 1/3 servings. So I need to figure out how many people I can feed. So each person is going to eat one of these thirds. So I can count my thirds, or I could say, okay, I have 3 servings in each pizza. Can you see that? There's 3 1/3 servings. So I could skip count 3, 6, 9, 12, 15 servings. 15 servings. Or I could do my multiplication. I have 5 wholes, and then there are 3 servings in each whole, so that's going to be 5 times 3 equals 15. Do you see how we got that? Now let's talk about the relationship between that 5 divided by 1/3 and that 5 times 3. We are doing the same thing in both cases because this model can represent both equations. But what you'll see as you move on into more division of fractions is that what we're really doing here is taking this division problem and then taking that second number, so the divisor, and we're getting the reciprocal. So we're flipping it to get its opposite, which would be 3/1 or 3. That's just a peek into what you're going to learn later. You don't need to worry about that right now when you're just dividing those whole numbers by the unit fractions. What I want to remind you of is that when you're doing these, it's always helpful to draw a model. especially if you have a context that you're given in a word problem. I highly suggest you always draw a model. And if you need some extra help or your child needs some extra help with math and fractions, please give us a call here at Hoffman Tutoring Group. Our number is in the details, as well as our website. We can't wait to hear from you. Thanks. Bye.